Hello once again, everybody. Welcome back to the 2015 Grade 11 Written Contest, the Hypatia. We're going to be looking at question number 2. For question number 1, see the last video we did, but we're on to question number 2 right now, so let's take a look at it together. Alright. In the questions below, A, B, M, N, P, Q, and R are non-zero digits. Alright. So 1A. A two-digit positive integer, AB, equals 10A plus B. So A and B are each of the digits here. For example, 37 is 10 times 3 plus 7. Alright. If AB minus BA is equal to 72, what is the positive integer AB? Okay, now they're phrasing it with a the, so we should get one final answer. That's probably something to note. Alright. So we want AB minus BA is equal to 72. Well, what does AB and BA actually mean? Well, it's 10A plus B minus 10B plus A is equal to 72. Okay? We're only given this information that AB stands for 10A plus B. That's the only information we're given in the question, so it makes sense to just substitute that in right away. We're also told that A and B are non-zero. That's something to keep in mind, certainly, but this is the only content we're given, at least in A part specifically. Alright, so we could rearrange these. We could group these as 10A minus B and B minus A, certainly. Or we could group our A's together and our B's together, and I think that might be the best way to do this. So 10A minus A plus B minus 10B is equal to 72. Okay. Well, that's 9A plus, it's going to be negative 9B, so minus 9B. Equals 72. Alright, well, we have a factor of 9 here, so you can say 9A minus B is equal to 72. Unfortunately, 72 is a multiple of 9. So A minus B is going to be 72 over 9, which is 8. So now we know a relationship between A and B, but we're asked for the number AB. Okay. Now, A and B are non-zero digits. So 1 is less than or equal to A, and B less than or equal to 9. So A and B are both within this range. Now, if I want A minus B equal to 8, well, at most, A could be 9. And at least B could be 1. So A minus B, or A equals 9 and B equals 1 gives A minus B equal to 8. Fantastic. Okay. Is there any other way to do it? Well, B is at least 1. The lowest B could possibly be is 1. If it were 2, 9 minus 2, that's not going to work. If A were less, 8 minus 1, that's 7. That's not going to work. 8 minus 2, no. Nothing's going to work. It's only 9 and 1 that will work. So just remember, I said that they're asked for the integer AB. There's only one answer, and it's true. A is going to have to be 9, and B is going to be 1. So this means, so AB is 91. Okay? Now, if we had missed the little preamble here that said A, B, M, N, P, Q, R are non-zero digits, we probably could have gotten A is 8, B is 0, and then we'd have 80 minus 0, 8 equals 72. Technically correct, but in math we don't like leading zeros. And I suspect that's why they said these are all going to be non-zero digits. Alright. So that's A part. AB is 91. And we could double check. 91 minus 19, that's absolutely 72. Quick calculator check, fixed it, works for us every time. Okay, now B and C are both written, and I suspect they're also going to involve two-digit numbers. B. A two-digit positive integer mn is given. So just like before, m and n are not going to be 0. They can't be 0. They can be 1 all the way through 9. Explain why it is not possible that mn minus nm equals 80. Okay, I'm suspecting that we'll have to do a proof by contradiction. So let's assume that we had such m and n, and see where it goes wrong. So suppose we had such an m and an n. So mn minus nm is equal to 80. Well, just like before, the smartest thing to do is probably to expand this out. It worked for us last time. And we can work our way down. We could show the same steps, or we can just sort of skip it because we showed it in A. We get 9 n minus m equals 80. And here's the difference. 72 was a multiple of 9, but I'm noticing 80 isn't. So m and n, they're their 1s, their 2s, 3, 4, 5, 6, 7, 8, all the way up to 9. And there are any assortment of them. So m minus n is definitely going to be an integer. It could be 1 minus 9, or it could be 3 minus 3, or it could be 5 minus 1, who knows. The point is it's an integer. But if I rearrange this equation, I get that m minus n equals 80 over 9. Which is not an integer. And that tells me that my assumption that such an m and n exist must be wrong, and so I can conclude the opposite, that no such m and n exist. So that was actually a rather quick written question. All right, C part. A three-digit positive integer, PQR, equals 100p plus 10q plus r, so I'm going to guess we're going to have to substitute this in at some point. If p is greater than r, okay, that's new information. Before we had non-zero digits and we had an expansion, but now we have another condition, p greater than r. Determine the number of possible values of PQR minus RQP. Okay. So now we're not asking to find PQ and R that give us a set value like we have before with 72 and 80. But we're asked for what possible values could we get. And to get a little idea behind this, we could probably pick some random PQs and Rs that satisfy this condition. So, I don't know, how about 816 minus 618? I'm getting 198. How about 742 minus 247? 495. I could probably keep going with this, but at least I've got 2 right now. But guessing check is not the way to go in math. You can't just be picking numbers out at random unless you're explaining why you're doing it. So how about we write down this equation and sub in. So PQR minus RQP, well, that's 100P plus 10Q plus R minus 100R plus 10Q. I could probably write that plus P on the top line there. Okay, so right away these 10Q and this 10Q are going to cancel each other out. And I could rearrange 100P minus P plus R minus 100R, 99P minus 99R, and I could write that as 99P minus R. And I'm guessing that this is why they chose P greater than R. And if we think back to just a second ago, I said that the difference of 816 and 618 was 198. Well, that's a multiple of 99. And 742 minus 247, that was 495, I said. That's a multiple of 99 as well. So it makes sense. So we get multiples of 99, but which multiples of 99 do we get? Okay. Now we're told P is greater than R. And then they're also non-zero digits, and we know that R is less than P, so we can definitely say that this happens. Okay? So R at the very least can be 1, P at its greatest can be 9. And the interesting thing actually to note is that Q plays absolutely no role in determining the difference of PQR and RQP. So that's kind of nifty. Alright, so what we could do is we could make a little chart. The number of values of P minus R is going to be the number of possible different differences. And just as a little note, because this difference is 99 times P minus R, the number of values of P minus R we get in our chart is going to be exactly the number of values of this difference here. All right. So we'll have values of P, we'll have values of R, and we'll have P minus R. Okay, what's the best way to go about this? Well, P can't be 1, obviously. It could be 2, and then we'd have R, and so we get the value of 1 here. Or we could have 3, and we'd get 2 and 1. We'd get a value of 1. Well, we already have that one. And a value of 2. P could be 4, in which case R could be 3, 2, or 1. And we could get a difference of 1, 2, or 3. We can have P is 5, and R can be between 1, and it still has to be less than P, so it's got to be 4, 3, 2, or 1. And that gives us a difference of 1, 2, 3, or 4. We notice a pattern, hopefully. 6, we have 5, 4, 3, 2, 1. That gives us differences of 1, 2, 3, 4, 5. How How about 7? And then we'll probably have 8 down here. And then we'll have one more to do on the next page. Difference of 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 1, 2, 3, 4, 5. We'll continue on the next page with 2 and 1. So that's 6 and that's 7. And then if P was 9, we could have 8, 7, 6, 5, 4, 3, 2, 1. We get 1, 2, 3, 4, 5, 6, 7, 8. So if we take a look at our chart, we can have P minus R is 1, 2, 3, all the way up to 8. So there's going to be exactly 8 choices. Only the numbers 1 through 8 appear in this chart. Now, it just so happens they all appear when P is 9, but they've appeared in other places along the chart as well. Eight different values of P minus R, that means 8 different multiples of 99. And that is exactly the difference that we want. So 8 different values there. That's C part, and I don't think there's a D part. Nope. So that's question number 2. All finished up on the 2015 Hypatia. I think it was a good question. Hopefully you agree. And not a whole lot else to say. I really liked it. And hopefully question number 3 is just as good, but we'll find out in the next video. So I'll see you guys next time.